Hello, everybody. We are going to now discuss Chapter 5 Elementary Particles and the Forces of Nature from the best selling book A Brief History of Time, written by Professor Stephen Hawking. Now, in this chapter, we are going to discuss about particle physics. What is particle physics? First of all, it is the branch of physics deals with the applications of quantum mechanics and study of subatomic particles as well. And you can see in this chapter, the beginning was from you can see here is the beginning of this chapter. You can see here is the Brownian motion explained here in this photograph, that the random motion in irregular motion, very irregular motion of microscopic particles in its most disorder way. This is called Brownian motion. Einstein used this Brownian motion to demonstrate that water was composed of atom, and this was the most significant discovery ever. And you can see it is the photograph of Joseph John Thomson, and here is the photograph of Ernest Rutherford, who discovered the atomic nucleus, and Thomson was the discoverer of electron. So both of these physicists are so important in the field of particle physics, and it was the name Joseph John Thomson who began the particle physics in 1897 by discovering the first subatomic particle, which is electron. And you can see is the explanation of the word atom, which means indivisible. uh, it was coined by Greek scientist Democritus, as you know, and a British chemist and physicist John Dalton in 1803 pointed out the fact that chemical compounds always combined in certain proportions could be explained by grouping together of atoms to form unit called molecules. So all these things are described in this chapter, all about uh, particles. This is the chapter all about particle physics, as we know. And now you can see here is the in here is the photograph of James Chadwick. So James Chadwick, who was the head of British atomic bomb project and during Second World War, and he was best known for his discovery of neutrons, for which he received the Nobel Prize in Physics in 1935. You can see, and here is the um, you can see here is the Rutherford Chadwick atomic model, and in this model you can see here is the atom, and in this model of atom there is in center atomic nucleus, which is very powerful due to its nuclear forces, and the orbiting particle near to the atomic nucleus, which is electron, and it was discovered by J.J. Thomson. As we know, atomic nucleus is we know was discovered by Rutherford, and atomic nucleus contains proton and neutron. As we know, neutron is the particle which is neutral, neutral charge, and have no charge, that means, and it was discovered by Chadwick, and proton was discovered by Rutherford. So all these particles, subatomic particles, which um, make the atom, all these particles are here described. You can see here is the nucleus, atomic nucleus, which is composed of neutron and proton, and the neutron is discovered by James Chadwick, was discovered by James Chadwick. So neutron, due to neutron's presence in this model, it is also known as Chadwick model of atom, uh, along with Rutherford, because Rutherford discovered it very fantastically. As we know, it is a classical model of atom, as we know, This is the planetary model. Just like Earth orbiting the sun, here is electron orbiting the nucleus of the atom, you can see. And here is the explanation of some important things, like um, one of the most important thing about subatomic particles is that in atoms there are not only neutrons, protons, and electrons, but nowadays there are total hundred of and thousands of subatomic particles were discovered out. And what are them? As we know, the recent discovery of subatomic particle is Higgs boson. Higgs boson is the one of the most important particle. It's the God particle because it gave all particle its mass. Now this is the importance of Higgs boson. But here we have to know that what are neutron and proton made up of. What is the particle? What is the name of the particle through which neutron and proton are made? So this is the most fundamental question in the field of particle physics, and um, we know nowadays it is discovered that electrons are subatomic particles, but neutrons and protons are not subatomic particles as well, because it contains um, more small particles inside it. It contains quarks. Quarks are subatomic particles because quarks make the electron, sorry, it makes the proton and neutron. You can see that Murray Gell-Mann, who was the one of the most important, prominent scientist of particle physics. As we know, he is the founding fathers of particle physics, who won the Nobel Prize in 1969 for the theoretical studies of the patterns of eightfold way in subatomic particles. You can see here is the joke, that is three quarks for master marks, and this joke is the beginning of the name of the term quark, because in this line we can see here is the word quark, which begins the word which is quark for a subatomic particle. So this was the beginning of the word quark for subatomic particle. And you can see here the flavors, how many flavors of quark are present in the world. As we know, there are six flavors of quark, which is which are up, down, strange, charmed, bottom, and top. So these six flavors of quarks are present in our nature. And you can see, as we know, there are particles with its antiparticles. As we know, particles are not only present, but also there is antiparticle which present with particles. So this is all about antiparticles. So antiparticles also present in our nature due to the presence of particles. Particles are of positive charges, so antiparticle is of negative charges. There are charges which are opposite in the case of antiparticles and particles, but not mass. Mass are same, but charges are opposite. Charges not same. It oppose with particles and antiparticles. So here is the um, you can see here is the six flavors of quarks and six flavors of anti-quarks. You can see here is the antiparticles of these particles. So you can see here is the neutron, which consists of two down quarks with one up quark. So what make a neutron? This was the question, fundamental question, whose answer is two down quarks and one up quark make a neutron. And what make a proton? two up quark and one down quark make a proton. So this is the answer of this fundamental question, which was discovered in 1960s, and you can see is the most important thing about this theoretical physics of particles, which is Paul Dirac's discovery of antimatter, and his prediction of antimatter, existence of antimatter, is the most important prediction ever. He discovered most important thing is that while researching on Schrodinger's wave equation with relativistic, he know that he knew that there is most important fundamental thing in the field of modern physics is that Schrodinger equation and Einstein's theory of relativity, because both of them are most important figures of the modern physics. So he was to combine both of these things. He combined Einstein's special theory of relativity with Schrodinger's wave equation, and he derived equation which is called relativistic wave equation for electron, for spin half particles, not only for electron, also for quarks as well. So this equation which is derived, which is a relativistic wave equation, relativistic Schrodinger's wave equation, this is called Dirac equation, and the Dirac equation predicts mathematically spinors, and due to which we can we have known that spinors have what half revolution, and there is another feature of the sphere. So that's why the Dirac equation makes a prediction of antimatter, antiparticle. So that's what most important thing, and most important thing in this photograph is there described. You can see here is what is written here. Elementary particles have a property called spin property is described. Spin 0 particle looks the same for all directions, which is here A. Example A is the example of this category, spin 0. And spin 1 particle looks the same when it is rotated through a full 360 degree. That means the example number B, it looks like same after the rotation of 360 degree, and spin 2 particles only need 180 degree. However, spin half particles must go through two complete rotation before they look the same. That means they have to go two complete revolution for which they will become looking same. So that's what the spin concept all about in quantum mechanics and particle physics. You can see here is the most important discussion of Paul Dirac's discovery of existence of antimatter, and Wolfgang Pauli, who received the Nobel Prize in 1945. Also, Dirac received the Nobel Prize in 1933 for his discovery of a new model for atomic theory, which is antimatter prediction. And Wolfgang Pauli received the Nobel Prize for his discovery of exclusion principle. You can see who discovered the exclusion principle, most important. And here is the photograph of Paul Dirac, and here is the photograph of Wolfgang Pauli. So this is the most important discussion in this chapter, and here is the discussion also about what is that exclusion principle. So here is also the discussion all about prediction of antimatter and exclusion principle. All this, you can see self and anti-self, when both touch each other they annihilate. So this is the example, a model to prepare in mind that how particles and antiparticles look like. Particles when collide with antiparticles, they annihilate each other. So this is the most important discussions, and you can see here is the chapter. and you can see interaction of particles. And here is the materialization of particles through photons. Spin particles materialize from neutral particles, and this is what you can see here: gravitational force between earth and sun, electromagnetic force between earth and sun. This is also, and you can also see here is the roulette wheel in which a spinning ball is described here. And you can also see here is the photograph of Steven Weinberg and Glashow. Both are the most important figures of particle physics. Weinberg received the Nobel Prize for his discovery of the unification of electromagnetic force with the weak force, you can see. And here is the thing: Abdus, Salamans, and Weinberg's theory described here. And you can see here is the explanation of quarks and colorless combinations. And here is the photograph. You can see here is the photograph of alpha detector, one of the end cap of the alpha detector of CERN, Geneva, Switzerland, which is the nuclear research organization at Geneva, Switzerland. And you can see here is the photograph from alpha detector. And here is the most important thing about Richard Feynman's discovery of Feynman diagrams. You can see here is the pictorial representation of how particles collide each other to annihilate and then materialize also with respect to time. And this is the Feynman diagram. Up quark and up quark collide each other and annihilate, and make down quark and anti electron. So this is the explanation of collision between particles and annihilation and materialization of particles. So this is the this is what, how to represent this process of annihilation and metallization through Feynman diagrams, through the pictorial representation. You can see through the graphic representation, which was developed in 1948 by Richard Feynman, a great physicist of our time, who received Nobel Prize in 1965 for his work in quantum electrodynamics. And he developed quantum electrodynamics through this diagram. And maybe the father of particle physics should be Richard Feynman, because his discovery of Feynman diagram let the complete and very easy calculations of most important and dangerous integrals of particle physics. How particles collide and annihilate each other and materialize into another particles. All these have integral equation, but these integral equations, which are so dangerous mathematically to solve, to calculate, are easily solved by using these diagrams, Feynman diagrams. So this is the advantage of Feynman diagrams, and which he developed in 1948. And what made him most famous was these diagrams. So here you can see is the mirror image of particle with right hand spin, with left hand spin. All these things are described. And here is also a theorem, which is CPT theorem, symmetry theorem, described, which is the most important theorem in particle physics also and fundamental physics also. um, the mathematical theorem says that any theory that obeys quantum mechanics and relativity must always obey the combined symmetry CPT. C means what? What means C? C is the symmetry. P also is symmetry. C means Charge. P means parity and T means time. T is the time, that means opposite time, and P means parity, opposite parity, and C means charge, opposite charge. So this is the explanation of CPT theorem, which is the most fundamental theorem in particle physics. And here is now what you can see, the next chapter, sixth chapter, black holes. And now here is the discovery, most important things about Stephen Hawking also, and his contributions also in the field of theoretical physics. We will discuss in next video. Thank you everyone.